When you look back at Earth's history, most of the big eras kind of just fade into one another. There's really no clear dividing line. But 66 million years ago, oh, that was different. The world didn't just fade out, it was violently erased. This is the story of that single day, the day that ended a 150 million year reign and changed the course of life on this planet forever. So let's really get into it. What actually happened? We're going to reconstruct the single most catastrophic day in our planet's recent history, minute by minute, horrifying minute. We're going to piece together the impact, the fiery chaos that followed, and the long, dark winter that came after, all from the clues that got left behind in the rock. All right, first things first, let's set the scene. Imagine the world 66 million years ago. It's basically a global hothouse. The CO2 levels are way higher, so temperatures are a good 5 to 10 degrees Celsius warmer than they are today. And the dinosaurs? They weren't just getting by, they were absolutely thriving on every single continent, including Antarctica. And we know the end was sudden. We know because of this, the KPG boundary. It's this razor-sharp line you can find in the rock layers all over the world. Below that line, you find tons of dinosaur fossils. Above it, nothing. They're just gone. And the crucial clue? That thin layer is packed with iridium, an element that's super rare on Earth's surface but really common in asteroids. It's the killer signature, literally written in stone. So to really wrap our heads around the sheer scale of this, let's just imagine we can suit up, become invisible observers, and travel back in time to see that fateful day for ourselves. Okay, so our journey takes us to the northern hemisphere. It's springtime, and believe it or not, we actually know that from the growth rings in fish fossils found near the impact site. So yeah, it was just a normal spring day, until it really, really wasn't. Suddenly, this thing appears in the sky, an object at least 10 kilometers wide. I want you to picture Mount Everest, okay? Now imagine it moving at cosmic speed, and it's heading straight for a shallow sea right off the coast of what we now call Mexico. When it hit, the energy release was, well, it's almost impossible to comprehend. At least 50 million megatons. Now, for perspective, the Tsar Bomba, the biggest, baddest nuclear weapon humans have ever set off, was just 50 megatons. This impact was 1,000,000 times stronger than that. The second it hits, it creates this fireball that's thousands of degrees hot and brighter than the sun itself. For hundreds, maybe even thousands of kilometers in every direction, the world is just instantly incinerated. Central America, it just ceased to exist. And because the asteroid slammed into the ocean, it created a mega tsunami. I'm not talking about a wave. I'm talking about a moving wall of water, maybe up to 1,500 meters high. It would have surged over 100 kilometers inland, just wiping entire coastlines off the map. But as insane as the blast and the tsunami were, they were really just the local effects. That was just the beginning. What happened next? That affected the entire planet, all at once. You see, the impact blasted trillions of tons of molten rock and debris, not just into the air, but all the way out into space. And then, all that stuff started falling back down, re-entering the atmosphere all over the globe, like a meteor shower from hell. As these trillions of tiny, fiery particles burned up, they basically turned the entire upper atmosphere into a planetary-scale oven. The pulse of heat was so intense and so global that it was like setting off a large nuclear bomb over every few square kilometers of the planet's surface, all at the same time. Forests, grasslands, they didn't just catch fire, they spontaneously burst into flames. Now, for any living thing that somehow survived the initial blast, the tsunami, and the global firestorm, the worst was actually still to come. The day of fire was about to turn into decades of darkness and freezing cold. What made this impact so ridiculously deadly wasn't just its size. It was its location and its angle. It was a perfect storm, a total worst-case scenario. The shallow angle of impact threw the maximum amount of debris up into the sky. And worse, so much worse, the asteroid hit a seabed that was rich in a mineral called gypsum. The impact vaporized it instantly, pumping about 100 billion tons of sulfur straight into the stratosphere. So all that sulfur creates this thick haze of sulfuric acid that blankets the entire planet. It completely blocks out the sun, and it transforms a warm, lush world into a cold, dark, and toxic one, almost overnight. The effect on the climate was absolutely catastrophic. global average temperatures plummeted by over 20 degrees Celsius. This impact winter wasn't just a bad season. It was a whole new era of bizarre freezing weather that probably lasted for about 30 years. So, with the sun blocked out for years, photosynthesis, the foundation of almost all life, it just screeched to a halt. On land, in the oceans, everywhere. Plants died, the herbivores that ate the plants starved, and then, of course, the carnivores that ate the herbivores starved. The simulations are brutal. They show the entire global food web would have completely collapsed in less than 6 months. And yet, in the middle of this complete global apocalypse, where 75% of all species were wiped out, some life survived. Which brings us to the great mystery. Why did the dinosaurs die while our tiny little mammal ancestors managed to pull through? Well, for the dinosaurs, their greatest strengths suddenly became their fatal flaws. Their huge bodies and their warm-blooded metabolisms meant they needed a constant, massive supply of food that just wasn't there anymore. Their complex life cycles, with vulnerable eggs and young that needed different food than the adults, just couldn't handle the total collapse of their environment. Mammals and birds, though, they had a few key advantages. They were small, which meant they didn't need nearly as much food. But more importantly, they were generalists. They were scrappy survivors, already used to living on the fringes. They could burrow underground to escape the heat and the cold. And they could eat the scraps of a ruined world. Seeds that survived the fires, bugs, and all the fungus that started growing on the decaying matter. The survivors were basically the planet's disaster specialists, built to thrive on chaos, while the old rulers, built for a stable world, simply perished. And that brings us all the way back from the deep past to right now. Because the story of that day, 66 million years ago, isn't just a cool piece of history. It's a profound warning for us. The sci-fi author Larry Niven really hit the nail on the head with this one. The dinosaurs, they had no choice in the matter. They were just passengers on a planet that was about to get smacked. We, on the other hand, we are not. We can see these things coming. We have telescopes, we track them, we understand the threat they pose. But let's be perfectly clear. As of today, if we found a 10-kilometer asteroid on a collision course with Earth, we have no proven technology that could stop it. The dinosaurs had no warning and no defense. We have the warning, but we're still scrambling to build the defense. And it leaves you with a pretty chilling thought, doesn't it? The last time this happened, the dominant species on Earth was completely wiped out. So what makes us so sure we'd be any different?